Now we're going to consider what happens when the denominator is 0. The denominator is 0 when either this factor is 0 or this factor is 0, giving us negative 6x minus 3 equals 0 or x plus 6 equals 0. We easily solve these equations to get x equals negative 1/2 or x equals negative 6. So let's consider if x equals negative 1/2. We want to determine what the sign of y is, whether it's positive or negative on either side of this 0 at negative 1/2. Okay, well, if x is a little bigger, well, first of all, okay, if x is negative 1/2, the denominator is 0, and all the other factors together become negative. That is, they give us a negative. Reason for that, if x is negative 1/2, then negative 8x is plus 4. Negative 6 is smaller, so this is negative. But this is going to be positive. Negative 1/2 of 8 is negative 4. Add 8, we get a positive. And negative 1/2 plus 6 is positive. So we have negative, negative, positive. And it's going to follow that whenever negative 6x minus 3, on whichever side of negative 1/2 this is positive, then the y value is going to be negative because these other three factors give us a negative. And conversely, the side on which it's negative is going to give us a positive. And I'm not sure I said that right, but we'll see here in a minute. Okay, so if x is slightly greater than negative 1/2, negative 6x minus 3 is negative. You can test that. And if x is greater than negative 1/2, then negative 6x minus 3 is going to be positive. And I just said that wrong. I read what I had here. And, of course, I want to look at what happens when x is slightly greater than negative 1/2 or when x is slightly less than 1/2. So when x is slightly greater than negative 1/2, this expression is less than 0. You can check that out. If it's x is slightly less than 1/2, then the negative 6x minus 3 is going to be greater than 0, which means that on the side, okay, well, let's just draw a line of demarcation here. On this side of the line, where x is greater than negative 1/2, or at least close to this line where x is greater than negative 1/2, the negative 6x minus 3 is going to be negative, which means we're going to have remember we have a negative here and a positive and a positive. We're going to have a negative here. That's going to make the value of y positive. So on the positive side of negative 1/2, the graph is going to be positive. At least that's going to be the case close to negative 1/2. On the other side of negative 1/2, well, the negative 6x minus 3 is going to be positive, so we have a negative, positive, 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 which is going to give us a negative. So over here, close to the negative 1/2, we're going to have negative values. Now you see, if we get further away from the negative 1/2, we get into the negative 3/4 and negative 1, and the graph can be positive or negative depending on where you are. Okay, so what we have now is near negative 1/2, the negative 6x minus 3 is near 0. Now you can check it out. None of these other factors are going to be anywhere close to 0 at x equals negative 1/2 or anywhere in the near vicinity of x equals negative 1/2, so that the denominator is going to be close to 0 and the numerator is not going to be close to 0. Denominator is going to be close to 0 because this is close to 0 and this isn't all that big. But if we make this close enough to 0, it doesn't matter how big this one is. This is going to make the denominator approach 0. Numerator is not approaching 0. What do we have? If we divide something that's not close to 0 by something that is close to 0, we get a very big either positive or negative result. Now in this case, on this side of the x equals negative 1/2 line, we're going to get a positive result. And if we're close to negative 1/2, it's going to be very big. So we're going to have something like this. And we're going to have a very big negative result on this side, which means it's going to be very big, but down in this direction. So we're going to have something like this. That's called an asymptote. Okay, so that's a vertical asymptote. Vertical asymptote at x equals negative 1/2, and the function is going to approach large positive values to the right, large negative values to the left. Now let's think about what happens for x plus 6. Okay, that means we're going to have an asymptote at x equals negative 6. We have a 0 in the denominator at x equals negative 6. It's going to give an asymptote at x equals negative 6. If x equals negative 6, then this is going to be positive. Negative 8 times negative 6 is 48, and the minus 6 is not going to keep it from being positive. But this is going to be negative, so we're going to have a positive and a negative, and we're going to have a positive. So we have positive, negative, positive. These three terms then are going to give us a positive. These three terms are going to give negative, 2 positives is going to give us a negative, so that when x plus 6 is positive, y is going to be negative. When x plus 6 is negative, y is going to be positive. Well, we can think through how that's going to work. I'm not going to go through the details of that, but I'll just assert the result when we look at the final graph of this rational function. And we'll do that in the next clip.